Today we will be talking about domain and range, which is a really important aspect of functions. So now that we have identified and, been able to work a little bit with functions, we're going to focus in on how do we express or describe the domain, which is the set of all possible input values. So that is domain. Let's go ahead and write that down. And the range is the function of a function, the set of all output values. That's our range. So let's talk about that for just a moment, because there will definitely be times, oftentimes, the domain will be all real numbers. Like, there won't be any restriction on what you can plug in. If you have an equation, for example, like y equals 3x, you could pretty much plug in just about any kind of number for x if that equation is not in a word problem or a real life situation. So I could put in fractions, I could put in decimals, positives, negatives, all kinds of numbers. So it might be, pretty often that the set of inputs, which is our domain, really is all real numbers. And then based on that, whatever possibilities are available to us as answers or outputs, then that would then determine the range. So it's really important that you understand that the domain is essentially a huge plays a huge role in what your range is. Let me give you an example here with this little picture. Let's say that for whatever reason, perhaps this is a real life scenario. Perhaps the input is, representing number of books, for example, right? All of a sudden, that really limits the numbers that really make sense as far as domain values, because if we're talking about numbers of books, we're not going to be dealing with negatives. We're not going to be dealing with fractions, decimals. So we might actually, in a situation like that, establish that the domain is whole numbers, for example. Okay, that's fine. So we say, okay, the domain is whole numbers. Only whole numbers work as far as inputting. And then according to this function, it multiplies by 3. So then I think about, well, what outputs come out of that, right? So I'll make a little list. Let's say that I'm allowed to have whole numbers like 0, 1, 2, 3, and so on and so on and so on as my domain, okay? Then what type of outputs will I get? Well, let's think about that, right? Is it really all whole numbers also? Could I have decimals? Could I have whole, real numbers? And the reality is that this really limits what output. So if I only plug in whole numbers, I'm actually only going to get multiples of 3 out. So if I plug in a 0, I will get 0. But if I plug in a 1, 1 times 3 is 3. If I plug in a 2, 2 times 3 is 6. If I plug in a 3, 3 times 3 is 9. And you can see how immediately, by restricting the values that I was allowed to plug in, or the domain, the range was actually also affected. And so I might write it like this. I might write this in set builder, maybe even interval notation in some cases. So this right here is what this is all about today, the domain and the range, being able to identify if you already have an established function, especially from a graph, being able to identify what the domain and range are for those. And if you have a real life scenario, word problem, decide what values make sense as input and outputs. Okay, so let's go ahead and get started. We're going to find the domain and the range of each of these functions. Now, the first thing that I want to draw your attention to is that we have two kind of different types of graphs. Sometimes they're separate points and they're not connected, and sometimes they are connected and there's either a curve or lines that are connecting this, and that will make a big difference in terms of how we write our domain and range. Okay, so on number 1, these are not connected. And so when it's not connected, your domain and your range is going to look a lot like my example that I had up here. It's specific individual points. And so by not connecting them, we're essentially making the statement that everything in between is not a part of our function, that it's really just these values that were graphed, okay? And one easy way to kind of determine this domain and range, especially when you have points, is to sort of list the ordered pairs. That sometimes helps. So if I want to think about this one here, I know I have a point at 0, 4. I have a point at 1, 4. I have another point at 2, 4. And then I have another here at 3, 3. Another at 4, 3. And the last one is at 5, 3. Okay, so a lot of times looking at the actual ordered pairs that they plotted makes it a lot easier to determine what is our domain, which is a set of X values that was used, inputs, and what is our range, which is a set of Y values, which are our output. And a lot like a mapping diagram, we're not going to repeat them, okay? We're not going to repeat them. If they repeat, we only need to list them once. So let's go ahead and finalize number 1. If I want to state what is the domain, then I want to open a set of numbers and list every X coordinate that had a point on it, which is essentially what I did when I made those ordered pairs. So it looks like I had a point at 0, 1, 2, 3, 4, and 5. So that is my domain, and only that. So there's our domain. Now when we go to the range is just a set of possible outputs. And I really only have 2 possible outputs. Even though I have 6 points, really I only had 2 outcomes. It was always either a 4 or a 3. And I don't have to repeat them. Like I said, I just basically need to say, when I say these are the possibilities, I'm essentially stating here the only possible outputs that we had were a 4 and a 3. And we do write them in order from low to high. And so 3 goes first. Just make sure that your numbers are in order. So 3, 4, that is the range. So these are the possibilities for inputs, but these were the only possibilities for outputs. And we just have to write it twice. Okay. Now I want you to notice how this is different than what we do on number 2. On number 2, our graph is actually a curve. It's a connected curve. And so, it looks like it starts over here where X is -3. And then, but after that, it would be almost impossible for us to list every point here, because since this is connected, like every single point that, once your pencil kind of goes down on the paper, every point you are touching is an input. It's a domain range, and a domain value. And a range value. And so that includes like every little minute decimal fraction in between, everything. And that is essentially an infinite list. And so we don't have the bandwidth or space or necessity to list all those numbers. It would essentially be impossible. So for this, we have 2 options in our toolbox that you've already learned. In order to describe this domain, which is a set of all of the X inputs, I'm going to use a compound inequality. That's one option. And also, you could also use this in interval notation. Okay, so we've done both of those. Let's see what that looks like. So let's start with the domain, which is a set of X's. So along the X-axis, right, I don't have any values over here. So like I said a moment ago, my values really start at -3. So if I'm writing this as a compound inequality, then I'm saying that -3 is essentially when I first start having X coordinates. But right at -3, I start having coordinates on the X-axis for this curve all the way, every single point, all the way to 3. Okay, so it's basically, my domain is every single number between -3 and +3. It's all of those real numbers. And since it's such a long list, we're not going to list them. We're going to essentially describe them as a compound inequality, or I could also use interval notation here with our boundaries, right? We've talked about how interval notation is all about the endpoints. So basically everything from -3, including it, all the way to +3, including it. Okay, so you should be prepared to write it in either of these formats. Let's talk about the range. So we're going to play the exact same game, but along the y-axis. So the y outputs, I don't have any y outputs down here at all. I come up. Looks like a 0 is really my first y coordinate. Okay, my very first y coordinate is at 0. So I start at 0 here. And then I have y coordinates, in fact, in both sides, all the way up. All of these points, they all have y coordinates that are on my graph, all the way up to 3. So this looks like it's a 3 here. Okay. And then it stops after 3. So it's everything from 0 up to 3. And sometimes, I don't know why, but it might help to put it sideways and just kind of say, okay, it started at 0 and it goes all the way to 3. And then after that, I don't have points again. So for my y, my range is everything from 0 to 3. And again, you should be able to be ready to write that in interval notation like that as well. Okay, so that is what domain and range is all about, describing those input values and those output values. Let's try a couple more. This is a really interesting one here. Let's do number 4. So number 4, let's talk about the domain. The big difference here between 2 and 4 is these arrows. They're actually a lot more important than you realize because they imply that it's not an endpoint like they were on number 2, but rather that it keeps going on forever. Okay. So for this one, if I look at our domain, let's start with domain or x's. Connected for sure. So we're not going to list them. We're going to write something that looks more like this. And if I look, I have points, if I start 0, I have x coordinates all around. And even though the graph kind of cuts off here and here, because of course we can't just make an infinitely large graph, these arrows play a really important role because they tell us that this pattern is going to continue. So that we can, the direction that they're pointing at, it is going to keep going and going and going. And so that means, since this is kind of at a slight angle, both of them, that it is going to continue to expand in both directions, to the right and to the left, forever. And so there is no end limit, right? There's no end point or limit on either side on the x-axis. This is going to continue expanding toward the left side. It's going to continue expanding toward the right side. You can see how they're just, it's kind of steep, but as it goes further, it is going to keep getting wider and wider and wider. So when that is the case, we're going to do all real numbers. That's familiar to you guys, right? And if we were writing this in interval notation, we would be going from negative infinity all the way to positive infinity, like that. And remember, we don't include those, okay? Same thing is going to happen on this one with the range. Since these arrows are going infinitely up and infinitely downward, positive toward the positive y-axis and toward the negative, it expands again in both directions. That is all real numbers. Or from negative infinity to positive infinity. Okay, there's our range. So you now know how to do an example with a separate distinct points. You know how to do a graph that is connected but has endpoints. And then you have one that is all real numbers. And sometimes it's a combination of both. So take a look at number 5 here. Okay, we'll do this one in class together, but I do want you to notice that it has an arrow in one direction only. So it does have one endpoint here, but it keeps going in this other direction. So that'll be a fun one to do when we get to class. I'm going to finish out with a mapping diagram here, and then we'll go to the back and do some word problems. So let's take a look at number 7. So if you take a look on number 7, this is a mapping diagram. Anytime you have a mapping diagram, it's going to be a listed domain and range. Okay, it's exact specific numbers. It does not have everything in between. It's not a connected graph. So this mapping diagram would look like number 1 or like number 6, and we will just list the domain and range. And to be honest, from a mapping diagram, it is a piece of cake because the domain, ding, 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 set of x's, and the range, ding, 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 set of y outputs, they're already listed for you. All you have to do is essentially rewrite them in that domain format. So if I want to know what were the set of inputs, they're already listed for me. That's the beauty of mapping diagrams. So I can see here that it's -3, -1, 2, and 4. Those were the possible inputs that were used. And then as far as the range, the possible outputs, it's just 0, 4, and 7. And again, just like with the mapping diagram, we would not repeat them. Even if, for example, -1 is with 4 and 4 is with 4, we only have to write it once. There's our domain and range. Okay, flip it over. Let's talk a little bit about independent and dependent variables and a couple word problems. So let's take a look. So you have talked about independent and dependent before, and so we're just going to equate those words and how they loop into this input, output, and domain and range that we've been working with. So let's first define them. The variable that represents the input values of a function is always the independent variable. Always think of like, yeah, I'm independent, I'm in control. This is the one that you can control. In science, they also call this the manipulated variable. That's the set of inputs. That's what you're controlling, okay? And then the variable that represents the set of outputs of the function is the dependent. Okay? And that one is the one that depends on what you plugged in. It's your output. It's your answer. This is what they also call in science as the responding variable, right? And so in any kind of equation, or well, really specifically function, when we say the y is a function of x, it basically means that y variable, right, depend or varies depending on what you plugged in, right? So the y value will be your dependent. That's your output. And it's going to depend on what you chose as an x value to plug in, which is your independent. Okay. So let's talk about identifying those. Let's try number 9. So on number 9, it says a function y equals 12x represents the number y of pages of a text a computer printer can print in x minutes. So we have this function. X is how many minutes have passed, and y is how many pages the printer has printed. Okay, so how many pages it's cranked out basically depends on how many minutes it's been printing, the amount of time that it's been going. Okay, so when we identify the independent and dependent variable, I'm going to use a little bit of an abbreviation here. Independent variable is the one that goes in your input or your x. And in this case, now never tell me it's x. Like when we say what is the independent variable, I'm talking about in the context of this problem. So if you say the independent variable is x, well, that doesn't help me. It's always x, you know, on a coordinate grid. What I want you to tell me is what it represents. So in this case, the independent variable is time, how much time it has been printed, and we are measuring that in this unit of minutes. Okay, so our independent variable is time, and then our dependent variable, so this should have been a V. Dependent variable is how many number of pages. So the number of pages that are printed depends on how much time the printer has been printing. Okay, so that's our independent variable and our dependent, our input and our output. They are synonymous essentially. And then it tells us, well, the domain is 1, 2, 3, and 4. So they just limited. They just dramatically limited our domain to just these 4 inputs. So then we want to know what is the range. Well, as soon as I limit the domain to those 4 inputs, then the output or the range is just the corresponding outputs. So the corresponding answers to these. So if the domain is 1, when I plug in a 1 here, 1 times 12 is 12. So I know 12 is an output. When I plug in a 2, 2 times 12 is 24. So I know 24 is one of the outputs. If I plug in a 3, 3 times 12 is 36. So 36 is an output. And if I plug in a 4, 4 times 12 is 48. And that is an output. And since those are the only 4 numbers I'm allowed to use as inputs, these are the only possible 4 outputs. As soon as we limit the domain, it limits the range, okay? The possibilities there. All right, guys, we are going to do the last number 10 here as in class as well. I'm going to circle it here. We'll do those couple of those as warm-ups, but that's what domain and range is all about.